Hi, I am Apoorv Bapat working with Altier Engineering. Today in this video I am going to show you how to do checking and editing the mesh. In this tutorial we are going to see that how to identify the shell elements connectivity, that is the 2D elements connectivity, how to correct that shell element connectivity problems. Then we will see how to review the model shell element to ensure connectivity problems were get connected. Then we will see the normals, how to view the normals of the shell elements. Then we see how to improve the mesh quality if some of the elements are get failing, and how to do remeshing to improve the mesh quality. So to begin with, once we start with HyperWorks Student Edition, we will select the user profile as Radius and say OK. Then click on Open Folder. Here you will find Open Folder. Click on the Open Folder to load the model in HyperWorks. So in this way, this is my model in which I am going to show you the checking and editing mesh. So we'll start this topics as first one is to review the model's free edge to identify shell elements connectivity problem. So to check that, you can go to Tools page. On Tools page, click on Edge panel. Edge panel is used to find out the connectivity. So make sure your component is highlighted and click on in graphic area, click on any of the on the elements. So entire component will get selected. Then on the tolerance value, enter the tolerance value as 0.1. Tolerance value signifies that if you are entering 0.1, that is if a gap between two nodes is less than 0.1, then it will recognize that there is no proper connectivity. If the gap is more than 0.1, it will not recognize that it is not having a proper connectivity. So tolerance value is the gap between two nodes. So generally 0.1 is which is being used to find out the connectivity issues. Then equivalent add is the lowest ID. That means if two nodes, I'll show you as an example. If these two nodes are not connected with each other, I'll zoom in. So say for these two elements, this one and this one, if this node, there are two nodes, say node this and this, they are not connected, and the gap in between these two nodes is 0.03, so it will come under this tolerance value and it will get connected. And the lowest ID means each node in HyperWorks assigned with a ID, node ID, which is known as. So every node, say this node is having a node ID as 31 and this node is having a node ID as 35. So equivalent add lowest ID means it will pick this node and will connect it to the 53rd node. So the connectivity goes from this to this, and retain the lowest ID. That means it will retain the position of node number 31. So in this way it will pick 53th node and connect it to 31 node number 31. Okay, and then the free edge option, that is find free edge, means it will find all the free edges. So first of all we will see what are the free edges. Logically, for 2D shell elements, the free edges should be available at the outer regions and around the holes, that this node is not connected with any other node, so it is a free node. So in this way the free edges should be at the outer, but if it's in between the connected segment, then we will remove that. So first click on free edges. So once you click on free edges, you will find that here it's showing a free edge. That means all these nodes are not connected with each other. You can see here also these nodes are not connected with each other. So now we will try to improve the connectivity of the element. So once you click on find edges, click on delete edges to delete these edges. Then again click on component and then click on preview equivalence. Once you click on preview equivalence, then it will find out the nodes which are not connected and having a tolerance value of 0.1, that is the gap between two nodes should be less than 0.1. It will pick all these nodes. So all these nodes are having a gap less than 0.1, so it has picked all these nodes. Once you click on preview equivalence, after finding the nodes which are not connected and having a gap less than 0.1, click on equivalence panel. Click on this option. So once you click on the equivalence option, it will, all the nodes which are not connected get connected automatically, and the connectivity goes like the equivalent add goes to lower ID and retain is also lower ID. So again, now we will find the edges. So click on find edges, and now you can see on the model, if you rotate zoom pan, that the connectivity issue has been resolved for the entire geometry, and now the edges are showing only at the edges on the corner of the model. So all the edges are now showing at the corner of the model, as you can see, or around the holes. So you can rotate zoom pan the model to view the connectivity, and you can see. So this is the logical. Also you can go to model browser and off the shell elements. So you will find that this is the edges which are being designed. So you can see. So again I will go to delete edge panel and delete the edges which I have created to check the connectivity. So in this way you can find out the connectivity and solve it out the connectivity issues in the model. Now we will see the next topic for this video as how to find the element normal and adjust them to the same direction. The element normals are used to if you are going to apply pressure on your model, so the pressure, to decide the direction of pressure, you need to find out the element normal, because the pressure will applied on elements. So element normal will play a important role when you are applying pressure on your model. So how to find element normal for your component, and if the normals are not in the same direction, then how to adjust the normals in for entire geometry in the same direction. So first of all I will click return to exit the edge panel. Then to find out the element normals, go to tools page. In tools page you will find normals panel. This panel is used to find out the element normals. So enter to normal panels. Make sure you are on element radio button. So select the element radio button. Click on the component for which you want to find the element normals. Select the vector display normal, so it will show you by arrow representation, and click on display normals. So once you click on display normal, you will see that the normals of this component is not all in the same direction. As you can see, some are in downward direction and some are in upward direction. So all the normals are not in the same direction. You can also see them by color representation. So if you toggle this vector display normals and toggle it to color display normal and say display normals, so you can see the blue color one is the downward direction having a normal, and the red color one is having an upward direction as a normal. If I go to the downward of this, so you can see these elements are showing an upward direction of normals, and these elements are showing a downward direction of normals. So in the direction of red color, the normals are there, so you can see by color. So logically, in a component, for a particular component, the normals should have, all the elements should have a equal normal if you are applying a pressure. So to adjust the element normal, select the component, select orientation element, click on the orientation element, and select any one element of which you want to convert it as a normal. So with respect to that element, all the normals will get adjusted, and then click on adjust normals. So once you click on adjust normal, you can see as per this element, all the other elements got the same normals. We can also view by arrow representation, say display. So you can see now all the elements are having normal in downward direction. So in this way you can view and edit the element normals. Now we can review the quality of elements using the check element panel. So then now we will see how to review the qualities, different qualities of an element. So we will see that. So I will first click on return to exit the normal panel, and then again to view the qualities, that is the different qualities for 2D element, I will go to tools, and then I'll click on check elements to enter to element check panel. Select the radio button for 2D, so it will show you the quality checks for 2D element, and then click on Jacobian. So once you click on Jacobian, you can find that okay, 11 elements are failing, and the minimum Jacobian value is coming as 0.53. So you can see that the minimum Jacobian value is coming as 0.53. So in this way, for different options, you can check the elements quality. That is for warpage, it is having a minimum warpage as 3 with 0 elements failing. Minimum angle tria, the minimum angle found as 32 degree. Maximum angle tria is coming as 92. Minimum quad angle is coming as 38, and maximum quad angle is coming as 147. Now as you can see, most of the elements are failing at the rib location. So by checking the elements, you can see most of my elements are failing at the rib location. So I will click return, and now I will go for a remesh panel to do the remeshing of these elements to improve the quality. So I will go to remesh the existing mesh, go to 2D page. In 2D page you will find auto mesh panel. So click on auto mesh panel. To do remesh, instead of surfaces, select elements by clicking on the drop box and select element. Make sure you are on size and bias panel. Keep all the other parameters as default. Click on any one surface elements along on this rib and base surface. Then click on elements and say by face. So it will select all the elements which is coming on this face. Now change the element size to 3.5 for this particular model. And then click on mesh. Once you click on mesh, it will generate the meshing, and now you just change the element size from this to this. In this way, you just change the element size along the edges, that is, change the number of elements along these two edges. Then go to mesh style panel. In mesh style panel, instead of auto decide, select free unmapped, click on set to all and say mesh. So once you click on mesh, it will generate the meshing as free unmapped. Now you can also check the qualities of these elements by going to checks radio button. So go to checks radio button and click on Jacobian. So by changing the elements, you can see the Jacobian has come as 0.68. Then you click on quad minimum angle, you can find that minimum angle is coming as 66 degrees and maximum angle is coming as 112 degrees. So all the elements which are getting filled in minimum angle quad and maximum angle quad has been passed. Also the elements which are getting filled in Jacobian is also getting passed. So in this way, by changing the element type, you can change the meshing. So once you, to improve the quality, you can go for the remesh. Once you have done with the remeshing and get the improved quality of the elements, click return to accept this mesh. Then again click return to exit this auto mesh panel. Now we will see how to remove tria elements from other areas of the model using edit element panel, split and combine sub panel. So there are different panels available through which you can remove the unnecessary tria elements available on your model. So you can improve the mesh quality, because in quad, if you are doing a quad mesh for structural analysis, the percentage of tria is 5%. So if possible, if you can remove the tria elements, you can remove it. So I will show you how to remove the tria elements from your model. So see, there are two tria elements at the edge of their component, so I will show you how to remove them. So to remove these, you can go in the 2D page. On the 2D page itself, select edit element. To remove tria elements or edit the elements, go to 2D page, select edit element panel. In edit element panel, select the radio button in front of split. This panel is used to split the elements. Then instead of display elements, select elements and pick the elements you want to split. So what I will do, I will split this element from here and combine these two elements, and then it will be converted into quads. So and click on point and draw a line . Pick these elements and draw a line and say split. The line which you will create, on that particular line it will split the elements. Now select the radio button as combine. To combine these two tria elements to form a chord. So select the radio button, combine to chord and pick these two elements and say combine. So it will get combined to quads. Again pick these two elements and say combine. So it will again move to and combine into quads. So in this way you can remove the tria elements from your geometry. Now sometime it happens once you go for editing the elements, the smoothness of your mesh reduces. So to improve the smoothness of your mesh, you can also go to tools panel, in 2D page, to generate a smooth pattern of your elements. Go to 2D page, select smooth, select the elements which you want to smooth. Select the iterations and keep the auto decide as auto decide, so it will automatically decide the shape which is best possible for this particular set of element, and click on smooth. So now you can see there is a smooth flow of mesh lines. So by using smooth panel, it will generate a smooth mesh pattern. Now if you go to element, again if you go to edit element panel in 2D page, so go to 2D page, edit element, click on element cleanup, make sure the display element option is on and click on cleanup. So once you click on cleanup, it will show you the elements which are getting failed in maximum angle, in warpage and in Jacobian. So to improve the elements quality, you can select nodes and click on the nodes and move the node till it's converted into yellow color, that is passed. Red means it's failed. So you can change it like this. So in this manner you can edit the quality of the elements. So if I untoggle this, so in this way it has the quality of the element get increased. There are one more option available to improve the quality of the elements. I will first click return to exit the edit element panel. Now the other option to improve the quality of the element is go to 2D page, select quality index panel. In quality index, these are the aspects in which your element is getting failed. So select the fail elements, so it will highlight only the failed elements. So these three elements are failing, and click on element optimize and just click on these elements to improve its quality. So once you click on the element, it will improve the quality of the element. So now you can see that percentage failure is 0. So there are no elements which are getting failed. So these are the some ways in which you can edit the geometry and improve the quality of your meshing. Now the last topic of this video is to add a ring of radial elements around a smaller of the two holes. On the smaller of the two holes, that is, as you can see on the bigger one hole, there is a smooth ring pattern is there of the elements, but in the smaller one there is no as such smooth ring pattern is available in this particular mesh. That is, there is no washer already available in this. So sometimes if you get a mesh file in which there is no washer is there, so to add washer, On the meshing itself, I will show you how to do that. So I'll first click return to exit quality index panel. Then on the model browser, click on utility tab. In utility tab, select geometry and mesh panel. In geometry and mesh panel, select add washer. So in geometry mesh, select add washer. Select any node along the circumference of the hole on which you want to create a washer. Then click on proceed. Once you click on proceed, it will generate one more window as add washer along a circular hole. So it is showing the hole radius as 2.99. The number of layers for the washer having the elements will select as 1. Then we will enter the width of the elements as 3, that is from this to 3 mm of distance generate a washer. Then we will select the minimum number of nodes around the holes to be 8. Or 12, because there are 1, 2, 3, 4, 5, 6, 7, 8 nodes are there, so we'll improve the number of nodes around the hole to 12, so it will be a smooth washer having a 12 elements. Then click on add. Select the option as width in the selection process. Make sure in the selection process the option is width, and click on add. Once you click on add, you can see the washer has been added on your geometry. So in this way you can edit the existing mesh data and improve the quality of your elements. So better is the improvement, better will be the results of analysis. So in this way, in this tutorial, we have seen how to identify the shell elements connectivity problem. Then we see how to correct the shell elements connectivity problem. Then how to review the model shell element to ensure connectivity problem were corrected. Then we have seen how to remesh and improve the quality of the elements, and also we have seen how to add a washer on the existing mesh. So in this way we have ended this video. Thank you.